Hey y'all, Braulio here, and do you want to know the hottest new pet trend? It's rocks. People love nature, whether it be pets, plants, or animals. People seem to have an affiliation with nature like no other. But what if, bear with me here, you're lazy? Well, let me introduce you to the Mesocosm. Mesocosms are fish bowls for people that are in lab coats and have PhDs. They are essentially small enclosed environments. They are done to investigate the effects of certain environments in an enclosed space. I repeated that 2 times. What essentially differentiates mesocosms to a terrarium or an aquarium is the fact that the mesocosm requires no human intervention once it's sealed. An aquarium, you'll need to feed the fish. A terrarium, you'll need to feed whatever creature you have in there. But with a mesocosm, the environment is supposed to be able to sustain itself. The key word here is supposed. So, we were required to do a mesocosm as a project. How did it go? I prefer not to say. So first, before I perform the experiment, I need to know how to properly set up a mesocosm. So a large container should be the way to go, preferably one made out of glass. The container should also be transparent enough to be able to see through. Also, ideally, the container must be able to have a way to completely seal itself so that no oxygen enters and that nothing that's inside could exit the mesocosm. Okay, so once all of this is done, we only need to check off one more thing off our list. Why does it say photometers? What elements are needed to create a sustainable mesocosm? To start, the organisms. The biotic key is essential in each environment. Without it, it can't even be considered an environment. For this, we need to determine the amount of autotrophs and consumers that will be introduced so that the mesocosm could be able to sustain itself. According to the IB Bio Guide, a food web needs minimum 1 primary producer, autotroph. However, it needs to be a lot of this type of primary producer. More primary producers, then you'll need in quantity less of each type. Then there's the consumers, which should average about 2 consumers, 1 primary consumer and 1 secondary consumer. We should also consider that these consumers in average should be small invertebrates like shrimp. Then there should be at least 2 decomposers as to recycle the organic matter that will be produced inside the mesocosm. The same thing applies with autotrophs that applies with decomposers. Either you have 1 decomposer, but you have a lot of that same decomposer, or you have various types of decomposer within your mesocosm. All of these factors combined are the organic biotic key that you need to sustain a mesocosm. And I know what you're all thinking. No, SeaWorld is not considered a mesocosm. The abiotic factors in a mesocosm are just as important as the biotic factors. Oxygen is key to any environment on planet Earth, and in a mesocosm it is no exception. Too much oxygen and your mesocosm will drown. Too little oxygen and your mesocosm will be asphyxiated. As to ensure that oxygen inside isn't in excess, you'll need to include producers. As to convert the carbon dioxide into oxygen, these help in the recycling process. Light is also incredibly important, and specifically light intensity. A lack of light will cause the producers to suffer as they wouldn't be able to photosynthesize properly, which in turn affects the entirety of the productivity of the mesocosm. Meanwhile, too much light might also affect the organisms inside it negatively. We also don't want any organism to suffer. unlike a certain marine park. So, to prevent any organism from harming itself, research should be done upon the tolerances of each organism that is planned to be introduced into the mesocosm. So now, before I perform my experiment, we need to answer an essential question. What is my hypothesis? Easy. In a pet battle, my pet rock would totally destroy my mesocosm. My actual hypothesis is that the majority of the motile organisms that I will introduce into my mesocosm will sadly die off within the first 2 weeks. But I do think that organisms like plants and bacteria will be able to live properly until the end of the experiment. So, as an officially licensed scientist with a PhD from the University of BuzzFeedQuizzes.com, I now know that I had to research my variables. For the variables that will be introduced and measured, the first one is water acidity, as the acidity of the water is essential to what lives in it, and too high of an acidity or too low may cause damage to the organisms that live. I think it needs to be measured. Water hardness is also an important variable to consider, as it measures the mineral count in the water. More specifically, it mostly measures magnesium and calcium levels in the water. I'll also consider water alkalinity, for the same reasons as water pH. Another variable is the amount of soil introduced, as too little soil will result in the producers not having where to be planted in, but too much soil may take up a lot of space and make the mesocosm more cramped, which will likely cause stress in my organisms, similar to the stress that students have in final exams week. But this was all just the setup so that now I can go outside and perform my very own mesocosm. So, on September 13th, I went out and got me a mesocosm from the local stream. For the environment, I decided to place soil from the riverbed because soil from land is different enough from soil already submerged, which contains nutrients from the stream and which is already submerged, so it can't cause some unfavorable effects in my mesocosm, unlike soil from the land, which has different minerals as to those found in the water, which may change my water's composition, specifically my water's hardness. I placed some moss, specifically some moss-covered rocks on the bottom, and I introduced some reeds that were growing alongside the riverbank. The reeds were used to being underwater most of the time, and they could hide smaller organisms that could help to fill in some of the niches in my mesocosm. So the reeds were chosen instead of other surrounding plants. I mean, the moss was also an easy choice, as it being one of the simpler plants anatomically speaking, allows it to be more flexible in environmental changes. I then decided why not, and I included some small mosquito fish. I thought that maybe since mosquito fish are known for being extremely resilient, as they've been invasive species in almost every continent, I thought that maybe there could be a chance where they could live well inside my mesocosm. I just want to make one thing very clear. Less fish died in my mesocosm than in SeaWorld. Me 1, SeaWorld 0. First, I filled the bottom of my jar with sediments from the creek. Then, I proceeded to fill out the jar with water almost to the top of my jar. Then, I grabbed some mossy rocks and some fallen decaying leaves, which I placed on top of the sediment. And then I yanked some reeds and placed them in my mesocosm. Finally, with a small net, I placed about 7 small mosquito fish inside my mesocosm. Once my mesocosm was done, I needed to research the tolerances for each of the species that I introduced into my mesocosm. I'm too lazy to do the recording myself, so here's the list. So, at the end, the abiotic factors included in my mesocosm were water, dirt, and rocks. The biotic factors were the mosquito fish, reeds, and moss. I'm not counting bacteria, as I'm pretty sure that even though there was bacteria, I didn't intentionally put it. It was more of a side effect of the mesocosm that happened to contain bacteria. Even though, yes, they technically still are part of the biotic factor. So now it's time for the most important part of the project. The research. Research is probably the most important part in any experiment. The analysis of the obtained data and figuring out what happened is like a jigsaw puzzle. Data research and analysis is essential for any self-respecting scientist. Luckily for me, I have no self-respect. So I managed to get the water pH, water alkalinity, and water hardness from the start of the experiment, and at the end almost barfed to get the results from those same variables. Water pH at the start was at around an 8. And by the end, when I recollected the data, it got to about a 7.6. Meaning that it slightly turned less alkaline. It's still a pretty close margin, so I don't think the effects aren't as noticeable, but it's a change nonetheless. Water alkalinity didn't change at all. It started as about 180 particles per million, and at the end, it ended up in the same range at about 180. However, water hardness probably experienced the biggest change. It started at about 85 particles per million, but it ended up with the particles per million at about 500. That is almost double the amount needed for the water to be considered very hard. But that wasn't the only thing I found out. I also found out the darker the color of water is, the closer it is to giving you superpowers. My mesocosm started out as clear as it could be. One could even say it was crystal clear. But by the third day, I started to notice that my fishes were starting to die off. And as the weeks went on, I could see less life, and I could see that the water was starting to become a more brownish, reddish color. By the third week, it managed to stabilize as an ugly brown color, and it stayed with that color up until the end of the experiment. I looked a bit into what could have possibly happened to my mesocosm, and it turns out that it may be that I accidentally created a humic lake mesocosm. For a body of water to become humic, it needs several things. First is stagnant water, which, my mesocosm wasn't running anywhere, so check. The second factor is the microbial degradation of organic matter. And boy oh boy, does my mesocosm sure have a truckload of that organic matter. Although, I can't say for certain if my mesocosm actually turned into a humic lake. I do think that it is the most likely option of what happened. High amounts of organic matter, a pH that tends toward a less alkaline rate, and having an emblematic brown color all are fit descriptions for my mesocosm, humic lakes, and public gas station restrooms. One factor that may indicate that humic lakes aren't what happened to my mesocosm is the water hardness actually. Water hardness usually measures calcium and magnesium, as I mentioned before. Humic lakes actually have low concentrations of calcium when compared to other bodies of water, And by my water hardness numbers, I feel like saying that calcium declined in my mesocosm is like saying that the earth isn't round or that the bioexam is going to be easy. It's just a lie. But no experiment has ever gone without its problems. As a great scientist and my inspiration in the field once said, take chances, make mistakes, and get messy. My mesocosm faced a lot of limitations. For example, the tools that I had at my disposal were honestly kind of limited. An improvement I would do if I were to repeat my experiment is to more carefully prepare which tools I would need for the collection aspect of the mesocosm. I only took a net for moss and small fishes, and the next time I would probably grab some gardening tools as to move plants from the riverbed into the mesocosm more properly, and I would probably take a shovel as to make the moving of dirt and rocks a bit more easy. Another limitation that I faced was the time of data recording and analysis. As I'm going to be honest, I really didn't manage my time all that well with the analysis of data. At the start, I couldn't accurately collect data for the first 2 weeks of my mesocosm. I have a basic outline, sure, but I couldn't take more specific notes on what happened. Next time, if I do it, I definitely would organize myself better at the start of the mesocosm so that I wouldn't face this problem again. A problem I faced when I made my mesocosm was regulating the amount of water that went inside of the mesocosm. I think that at the end of the day, I may have overfilled the mesocosm with water, and I feel like that may have caused it to not have as much air as it should have had. I feel like this eventually did help with the more propagation of microbial matter, and I feel like this may have been one of the main causes as to why my organisms, generally the plants, didn't survive all that well as they could have survived. Another limitation that I had was the size of the jar that I used for the mesocosm. I used a 3-liter jar. However, even then, the jar may have been too small to include some of the factors like the rocks and the reeds. I feel like if I were to repeat the experiment, either I would include smaller plants and smaller rocks, or I would include a larger jar so that those plants didn't feel as stressed as they would have in my mesocosm. The last problem that I faced with my mesocosm had more to do with where I managed to make my mesocosm. I made it in a seasonal creek, one where the water level is mostly determined by rainfall. I do feel like the seasonal factor of the creek was affected when I placed the stuff from the stream with running water into the stagnant water of my mesocosm. At the next time, I would make my mesocosm from water that is from a pond, or I would make it from water that is from a stream but not one where its influx is determined by rainfall. As this temporal aspect, I feel like really didn't help all that much with the survivability of my organisms. But the quality of life index in my mesocosm is still higher than that of SeaWorld. If I were to do the experiment again, there are definitely a ton of aspects that I would change from my project. I feel like the most important is just a better organization from myself and a more dedication to the time of data research and analysis. Another aspect that I would change in my experiment would be to balance the amount of water inside my mesocosm, as I mentioned. Lastly, I do kinda regret not making 2 mesocosms instead of 1. I wouldn't have done it to test anything out. I would just like to do 2 mesocosms with some slight changes just to see how it would have played out. I feel like it would have made the experience more interesting and more personal for me. At the end of the day, I do feel like I learned a lot from the Mesocosm. I learned a lot about how balances in an ecosystem are incredibly delicate. And I feel like this does serve as a microcosm for a representation of how human intervention can really affect an environment, whether it be as small as transplanting some parts of that environment to another place. I feel like this does serve to show how human impact is definitely a big cause of the environmental problems that we are facing today. Okay, so now that I finished my Mesocosm, I can safely say Mesocosms are a sham created by the jar companies to sell more jars to the scientific community. It's true, Mesocosms are worth nothing. Spread the word. The jar community is latching on to this. Please, spread the word.